Good day everyone. I am Rialyn Albrastini from BTBT and FSM student. So in this video presentation, I will going to discuss my chosen topic and I will give you one problem for you to understand this topic. My chosen topic is all about truth table equivalent, statement, and tautologies. So my problem is prove that P or Q are not P or Q are equivalent. So for now, I will give you the truth table for conjunction, disjunction, negation, and conditional statement. So the truth tables for conjunction, we have three columns because the formula is 2 raised to the power of n. So our n is 2 since we have two statements which are the P and Q. So as what you observe in the P column contain false, false, true, true, as well as the Q false, true, false, true. And our P and Q contain false, 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 true. Because if we talk about conjunction, true when both P and Q are true. So look at the row 1. The P is false, then the Q is false, so that the conjunction is false. The next row is the P is false, then the Q is true. Therefore, the conjunction is false because the P is false as well as the row 3. And look at the row 4. The P is true, then the Q is true. Therefore, the conjunction is true. Next is the truth table for disjunction. If we talk about disjunction, the truth values is false when both P and Q are false. So as what you observe in that table, the P is false, then the Q is false, so the disjunction is false. Then the P is false, then the Q is true, so the disjunction is true, so on and so far. So it is very opposite for the conjunction because the conjunction is always true when both P and Q are true. But if we talk about disjunction, always false when both P and Q are false. Next is the negation. We have four columns, the P, Q, not P, or Q. So if we talk about negation, true when P is false, then false when P is true. The first row is the P is false, then the Q is false, so the not P is true. Then the last one is the conditional statement. We have three columns. If we talk about conditional statement, false when P is true and Q is false. So the first row is the P is false, then the Q is false. Therefore, the conditional statement is true. So for now, to show the equivalence of P or Q and not P or Q, we must first create two truth tables and compare their final outputs. So we must refer the truth table of what I've discussed earlier to know their truth values. So these are the two truth table that we must compare their final outputs so that we can identify that they are equivalent. So the first table contain P, Q, P or Q. Then the second table is contain P, Q, not P, or then the Q. So as you can see the two truth table, they are the same. Because in identifying that they are equivalent or not, we will see the column OR. So the first table, we will see the P or Q. Then the second column, we must look the OR column. So the first table contain false, true, true, true. Then the second table is contain false, true, true, true. Therefore, the P or Q and not P or Q are equivalent.